Today we're going to learn about linear regression models. So linear regression models help us predict or kind of analyze how two variables interact with each other and the effect of the independent variable on the dependent variable. So we have the example: the American Institute for Health decided to analyze the relationship between the total fat and total calories for particular food items. Here is the table of data they collected. So you can see here's the food item hamburger, and a hamburger typically has 9 grams of fat and 260 calories. So what effect does the total fat that an item has have on the total calories that the item has? So you can see the cheeseburger has 13 grams of fat and it has slightly more calories. It has 320 calories compared to the hamburger that only had 260. So you can see kind of as the total fat is increasing, says we're changing and we're increasing in this variable right here, you can see that the change here is also increasing, right? Maybe not the same thing, and then if we look at the quarter pounder, you can see there's more grams of fat, and you can see that 420, the total calories, is going up as well. So there's a relationship between these two variables, and what we're going to do is we're going to use a linear regression model to figure out exactly what that relationship is. So using a linear regression model, find the line of best fit for the following table of data comparing total fat in grams and the amount of calories a food item includes. Let y represent the dependent variable being measured and x represent the independent quantity. Round the slope and the initial value to the nearest whole number. Okay, so we have here two variables, and what we're going to do is we're going to determine which one of these two variables is independent and which one is dependent. So you can see that it seems like the total grams of fat affects the total calories an item has. So we're gonna say that this total fat is the independent and the total calories is the dependent. So we have our model here. We have our model y equals mx plus b. So this is the equation of a line that we've learned, but with regression models the equation is a little bit different. It is y equals c plus bx. So I don't want you to get confused. There's a relationship here. Y is the same here, x is the same as x in the slope intercept. Now b has now become the c, and the position that they come in has switched. So the constant, right? And then our m, our slope, is actually considered to be b. So we can convert this to y equals b plus mx if we wanted to. That would be the same form. We're going to use Desmos to do this, so what I'm going to go ahead and do is I'm going to open up Desmos. And when you have Desmos open, what you want to do right away is you want to type in this equation. This is going to help us get the line of best fit. So we have y1, and then there's this tilde, is the same as mx1 plus b. So we're going to type this in, and then in our second line, we're going to jump down to our second line, and we're going to go over to this plus add an item, and we're going to type in the table. So now I've got a table, and what I'm going to do with this table is I'm going to type in all these values. So I'm going to go ahead and pause the video, type in these values right now. Okay, so you can see I've just transferred over the table, and I've kind of double checked to make sure I've inputted when the fat is 30, the calories is 530. When the fat is 30, the calories is 530. I've double checked it, and now you can see as I typed in this table, it put the points on this graph. So you can kind of see these points are in a straight line, not a perfect straight line, but that's what we're going to use the regression model for. So we're going to use the regression model to draw a perfect line, or a line that is equal distance between each of these points, and this is the equation that we can use to predict what future fat items might have in terms of their fat content and their total calories. So I've typed it in. You can see the points. Now what I need to do is I need to make sure that this is x1, so I'm going to delete this 2, make that 1, and delete this y and make that 1. Now you can see up here it's given us some stats. So this r squared, important to note, is the correlation coefficient. So it tells you how strong the linear relationship is between these two variables. So r squared equals the correlation coefficient. And that tells you that it's a pretty strong linear relationship. A 1 would be a perfect linear relationship, so it's 0.95. It's almost at a 1, so it's almost a perfect linear relationship, and linear meaning that it's a straight line, right? Like as one variable changes, the second variable changes the same almost every single time. And then we've got our b value right here, which is this value right here. So we can go ahead and start filling in our slope and our b value. So we've got our b value and we've got our m value. So our equation is y equals 11.731 plus our slope is, whoops, I wrote that wrong. Our b value is not 11.731, it is 193. So our starting value is 193.85. And our slope is 11.731, and then we can put the x. So the equation, really all we had to do was type in this general formula, which we're always going to use to run a loop, to find the line of best fit, and then type in the table of values, and then change the x so that the subscript matches the subscript of the equation, and it gives us this line of best fit. Kind of uses. So now we can predict, okay, if a food item has 100 grams of fat, how many total calories does it have? Well, we can come up here to where this 100 is, and it looks like it's going to have about 1,370 or 69 calories, right? So we can start using this line to predict the relationship of these two variables and how they're kind of behaving, right? So let's go ahead and go back to the problem. Got our equation, so we've answered question number 1, except we need to round the slope and the initial value to the nearest whole number. So I can just rewrite this as y equals 193, 0.85, we can round up to 194, so 194 plus, and then we can round up 7.7 to 12, so 12x. So this is question number 1. Now question number 2 says, based on this data, does the relationship appear to be linear? Well, we can go back to the table and tell for sure. Yes, the data points create a almost perfect line, right? And remember, we can just use the correlation coefficient. If this is pretty close to 1, then that means, yes, the data is almost a perfect line. So using this model, estimate what is the estimated additional amount of calories for a food item that has 15 grams more of fat than any other item listed. So to answer this question, I just kind of want you to think about the equation that we've found using the regression model. This represents our starting value, our initial value, and then this represents our change in the y over the change in the x. So what they want to know is, what is the additional amount of calories? So what is the y if our x is changing 15 grams, right? And so the way that we find this is by plugging in 15 grams into our x value, which represents our grams, our total fat grams, and then just simply multiplying it by 12 to figure out what the additional amount is. So let's just say in a hypothetical situation that the total amount of total fat is 100, and that is 200 grams of total calories, right? What they want to know is how much total calories would there be if a food item had 115 grams of fat. So they want to know what this distance is, or what the change is between our largest point, or our largest data point, and 15 more. So they're trying to figure out, okay, what is this change right here in our y, right? We know the change here in our x is 15. We want to know what the change in the y is. So what we're going to do is just going to simply multiply the input by the slope, and that's going to tell us how much more, right? So we're going to multiply here 12 times 15, and we get 180. So as we change 15 here, we change 180 here. So what was the additional amount of total calories for a food item that has 15 more grams of fat? Well, the additional amount is 180 grams of total calories, or 180 total calories.